Tell whether the rates of change are constant or variable. Okay, so whenever you look at a table, if it's not labeled with X and Y, you can just label it alphabetically like that. Okay, so to find a constant, there's a formula. It's Y divided by X. If I get the same number every single time, that will tell me that that table has a constant, and that's telling me it's proportional. Like I could write the equation like y equals kx. Okay, so I'm going to take 1 divided by 3. I'm just going to leave my answer on there so I can see if it changes as I go. 4 divided by 12, 9 divided by 27, 25 divided by 75. So I divided all 4 columns, and I saw that I did get a constant answer, the same answer over and over. So they just wanted me to tell whether it was constant or variable. So I got a constant. If I wanted to, I could write the equation, y equals that 0.3 repeating. If I would have just changed it to a fraction, it would have said 1/3. So I just put that in the place of the k in y equals kx. Okay, so number 2. Just going to divide. I have x's and y's. Okay, so I look at the bottom. So 6 divided by 2, 12 divided by 4, 25 divided by 9 is not pretty. I did not get a constant answer of 3, so this is variable. Okay, on number 3. Okay, I'm doing 1 divided by 16, 2 divided by 64, 1 divided by 16, 2 divided by 64. Did not get a constant answer, so this is variable. To check this last table to see if it is constant or variable, so 38 divided by 2, let's clear out the other ones. 76 divided by 4, 133 divided by 7, good so far. 171 divided by 9, it's constant, because every single time I divided the y by its x value, I got 19. So I'd write the equation y equals 19x would fit the table. So if I took any of these x values and I plugged it in for x and I multiplied it by 19, it would give me that y number that was below it. Erica walks to her friend Philip's house. The graph shows Erica's distance from home over time. So you can see as time goes on, she's getting further and further from home. Find the rate of change from 1 minute to 2 minutes. So they're talking about 2 specific points on the graph. How far she was from home at 1 minute and how far she was from home at the 2 minute mark. Where they say rate of change, I want you to write slope. They're the same thing. Okay, so since it's on a graph, I could do rise over run. It's kind of set up for, they're using the slope formula where I subtract the y's and subtract the x's. So let me go ahead and put down here, they're counting by ones, so I'm going to fill in that graph. So they were talking about right there at 1 minute, so I can see she's 200 feet from home. And they're talking about the 2 minute mark, so she's 400 feet from home. I'm going to write out these ordered pairs. So 1, 200. And then this one was at 2, 400. So I was just grabbing their x and y values from the x and y axis. Okay. They want me to really use the slope formula. So I'm going to label x and y X and Y and give it the 1s and the 2s. Okay, so the formula goes y2 minus y1 over x2 minus x1. So you can see that they've already set up that big fraction bar for me. The formula starts with y2, and they've already filled in the 400. They've even put the minus sign over there for me. So I just have to go and grab the y1 number, which I can see was 200. Then on the bottom, it says to start with x2, and they did fill in the 2, and they filled in the subtract for me. So it's telling me to grab x1, which is just 1. 400 minus 200 is 200. 2 minus 1. 200 divided by 1 is 200 feet per minute. So the rate of change, or the speed that she was walking between these 2 points, was 200 feet per minute. Whenever you have to label a rate of change, like if they didn't have the wording filled in for you, you subtracted the y's first. So you go and get the meaning from the y-axis. It was labeled with feet. So that's how they started how they named this rate. It was the feet per. Okay, so on the bottom we subtracted the x values. So then they went and got what was on the x-axis. What was that meaning? So it was feet per minute. It says find the rate of change from 1 minute to 4 minutes. Okay, I'm going to go ahead and do like rise over run on this since it's on the graph. So find your 4 minutes, because we already had a point at the 1 minute. So I want you to find your 4 minutes and go up and put a point. Then I want you to start at that lower point, so the 1 minute mark, and do your rise straight up and your run straight over so that you have that right triangle. Notice that this y-axis is not counting by 1, so I'm not going to say 1, 2, 3, 4 whenever I go and count my rise. I have to count by what they are counting by. And if you don't know, I'd go back to the first ones that they labeled. So I know 0 is the very bottom. There's a mark that's not labeled, and then there's a 200. So there are 2 little intervals here that are equal size, and it goes up to 200. So I take that first number and I divide it up into that many pieces. So 200 divided into 2 equal pieces tells me that it's counting by 100s. Okay, so for my rise, you count by 100s. Got 600. Now for my run, we can count normal because their x-axis was just by 1s. 600 divided by 3 is 200, and you label it again. Since we got the rise number, I get the y meaning, so feet per, and then I did my run last, so I go get that x-axis meaning where it says minutes. Okay, and this line has a constant rate of change, or a constant slope, like it never got steeper or less steep. So the answer that I got for that 1 and 2 minute mark should be the same as the 1 and the 4 minute mark, because it's on the same line. It doesn't matter which points I use. Whenever I get the slope, I can use any 2 points and get the slope of a line.